Okay, my name is Sundolo Afem Godogwe. Welcome to today's stochastics processes class. So today we'll be checking out to set up the transition matrix. So we have an example here, a tennis game. So here we have our transition diagram. So we have from deuce, we have Venus ahead represent as A, Venus behind represent as B, and Venus wins represent as W, and Venus loses represent as L. So we can see the arrow. This arrow move from D to Venus ahead. We have P. From D to B, which is Venus behind, we have Q. Then we have from Venus ahead back to D, we have Q. From Venus behind back to deuce, we have P. And we have from Venus ahead to Venus wins, we have P. We have from Venus behind to Venus loses, we have Q. So we want to set up the transition matrix. So don't forget, the first thing is to list out the states we have here, which is deuce represent as D, we have Venus ahead represent as A, Venus behind represent as B, Venus wins represent as W, and Venus loses represent as L. Then also list our states here. We have deuce represent as D, Venus ahead represent as A, Venus behind represent as B, Venus wins represent as W, Venus loses represent as L. Alright, so let's now construct the transition matrix properly. So we have from D to D. So there's not any arrow moving from D to D. So here we have 0. From D to A, is there any arrow? Yes, we have. Okay, let me change the pen. So we have from D to A. We have from D to A, which is P. So from D to B, we have D to B, which is what? Q. But we don't have from D to W. So put 0. And we don't have from D to L. So with this also will give us 0. So that again. So let's check the next one. We have from A to D. From A back to D, that is Q. We have from A to A, that is 0. From A to B, that is 0. From A to W, that is P. And from A to N, no, we have 0 also. So next shall be from B to D, we have P. And from B to A, no, we have 0. From B to B, we have 0. From B to W, now we have 0. So we have from B to L, and that is Q. Okay, so from W to D, W to D, now we have 0. From W to A, 0. W to B, we have 0. And W to W, that is 1. Okay, and from W to N, that is 0. So because it wins, that is 1. So back to himself. So L to D, we have 0. X to A 0, X to B 0, X to W 0, and for X to N we have 1. Alright, so let's take another example. Example 2. Example 2 we have a survey of American car buyers indicates that if a person buys a Ford, that is the name of the car. Sorry, let me write that again. Buys a Ford, there's 60% chance that their next purchase will be a Ford. While owners of a GM, this is also another name of the car, of a GM will buy a GM again with probability of 0.80. So the buying habit, so you have to find, construct the transition diagram and to the transition matrix. So let's check the solution. So the two possible states we have here is a Ford car, present as F, and a GM car, present as G, if you read the question properly. So let me even put it in a square bracket because my circle is not properly drawn. As a Ford, then a G. Alright, so a survey of American car buyers indicates that if a person buys a Ford, there's 60% chance that their next purchase will be Ford. So a Ford, so they will buy a Ford again. That's 60%, and that is 0.60. So that means that their next purchase will be GM. That will be 0.4. Why owners of GM will buy a GM again, its probability of 0.8. Buy a GM again, 0.8. So they will buy a Ford in their next car, that will be 0.2. So this gives us the transition diagram. So let's check the transition matrix now. So with the aid of this diagram, I can easily set up the transition matrix. So the first we have to list our state here: Ford and G, Ford and G. So if the current state is Ford, the next state will be Ford, and that is the arrow going back to Ford, which is 0.6, and then that's 0.60. That is if the next position will be G, that will be 0.6, 0.4 rather. And if it is G, although that is to be G again, is 0.8, 0. And if it is G, the power that will be Ford, will be what? 0.2, 0. So this gives us the transition matrix. Alright, so here we stop for today. Thank you for watching.